So welcome to my YouTube channels. Today I am going to discuss the reaction turbines about that. Velocity diagram for the impulse reaction turbine, also known as Parson turbine. Also known as Parson turbine. So in that Parson turbines, what we will see here, both in this turbine, fixed blade and moving blade, both will be equal in shape and size. So see this red color line drawn. So shape and size both sides will be equal. That means VW1 minus VW2 is equal to VB. So blade velocity. So in the reaction turbines it will not be equal, but here in Parson turbines fixed blade and moving blade both will be equal in shape and size. Then in that case what will happen? V1 will be equal to VR2. V1 will be equal to this steam velocity at inlet will be equal to relative velocity at outlet. Then steam velocity at outlet will be equal to the relative velocity at inlet VR1. So V2 is equal to VR1. These are the conditions for the impulse turbine. And also VF1, flow velocity both inlet and outlet will be equal. In that case, axial thrust, if you will see the axial thrust, M VF1 minus VF2. So it will come 0. Axial thrust will come in the reaction turbine will be 0 because V1 flow velocity will be equal. Now, angle regarding. Suppose this alpha, nozzle angle, or also known as outlet angle of the fixed blade, will be equal to the inlet angle of the blade. Inlet angle of the blade, theta. Beta is equal to theta. Beta what is? Inlet angle of the fixed blade equal to inlet blade angle. Alpha, nozzle angle, outlet angle will be equal to outlet blade angle phi. Outlet blade angle phi. So theta and phi, theta and phi is inlet and outlet blade angle. So phi is outlet blade angle, theta is inlet blade angle. So this is the relation happening in the Parson turbine. So flow velocity equal steam velocity at inlet equal to relative velocity at outlet. Steam velocity outlet is equal to inlet velocity at relative velocity. So these are the conditions. And these all notations always I used to give. So see this relation is coming in Parson turbine. VB, blade velocity always will be equal to the real velocity at inlet minus real velocity at outlet. Then what is the stage efficiency here? In the here stage efficiency in the reaction turbine, work done per second per stage is nothing but enthalpy drop per second per stage. So work done already you know M VW1 plus VW2 into VB is work done. Enthalpy drop it is M HD into 1000. Why multiply 1000? Because HD I taken kilojoule per kg. If HD value will take from the steam table, always they given the kilojoule per kg. So that's why multiply 1000. So HD directly value will take from the steam table kilojoule per kg. Then this unit will be the no unit for inlet. See what is unit for the numerator? Kg per second. First mass and mass will get cancelled. Then what will be there here? Velocity. Meter per second into meter per second. So it is coming meter square per second numerator. Then HD. HD unit what I told? Kilojoule per kg. So kilo okay remove. Joule. Joule nothing. What is Newton meter per kg. Then Newton means what is? Kg meter per second square into meter by kg by 1. So Newton meter per second. Newton means kg meter per second square Newton. So kg get cancelled. What is coming? Meter square per second square. So both numerator and denominator will be equal. So it will get cancelled. So efficiency no unit. So this efficiency, this unit regarding you have to be very clear. So HD unit taken 1000 multiply y because unit I taken HD kilojoule per kg for that only. So this is the unit analysis you should know. So efficiency no unit. See meter square per second here, and if we'll solve joule per kg, it is coming also meter square per second square. So both will cancel, no unit. So this is the stage efficiency. Now what I am going to prove, degree of reaction is 50%. This is very important derivation and questions, short questions, long questions, everywhere they are asking. Prove that a degree of reaction is 50%. What is degree of reaction? It is the ratio of enthalpy drop in moving blade, enthalpy drop in moving blade by enthalpy drop in the entire stage. So this is the definitions of the degree of reactions. Enthalpy drop in moving blade, it is the ratio of enthalpy drop in moving blade by the enthalpy drop in entire stage. So enthalpy drop in moving blade also known as gain in kinetic energy, is also known as gain in kinetic energy, and this is the entire stage work done. So this is the work done. Enthalpy drop in entire stage nothing but work done. So what is gain in kinetic energy? You know kinetic energy is equal to half mv square. So this will be relative velocity. No? So mv you take common, vr2 minus square, vr1 square. This is the gain in kinetic energy. What is work done? We know m vw1 plus vw2 into blade velocity. This is the work done. This is the work done. vr2 square minus vr1 square, gain in kinetic energy and work done. So okay. So now this mass get cancelled. What is finally is coming? Finally coming vr2 square minus vr1 square divide by 2, it will come denominator 2 vw1 plus vw2 vb will give the equations number 1. Will give the equation number 1. Now what we'll do? vr2 and vr1 will replace now. So now vr2 minus vr1 is equal to, so vr2 minus vr1 is equal to v1 square, give square here, so v1 square, vr2 is equal to v1 square minus vr1 is equal to v2 square, vr2 is equal to v1 square, v2 square. So I wrote vr2 square is nothing but v1 square and vr1 square nothing but v2 square I wrote. Now we will take the value of the v1. So v1 means we have to take this angle AFE. We will take the triangle. What is AFE? This is called alpha. This is VW1. This is V1. This is V1. So I need V1 is equal to. So here V1 is equal to what we can write? Because this is right angle triangle. So hypotenuse is equal to VW1 whole square plus VF1 whole square. If V1 square is equal to, if this is square, na root will come. So root we don't know, don't want. V1 square is equal to, we know VW1 plus VF1 square. Similarly, V2 where? This angle, beta angle. Again we will draw here beta angle. What is EAD? EAD. So what is this one? VW2. What is this one? V2. What is this one? VF2. So here also we can write V2 is equal to VW2 square plus VF2 square. Now we will replace this. Give equations 2. From equations 2, V1. What is V1? VW1 whole square minus plus VF1 square minus V2. V2 nothing but VW2 square plus VF2 square. Okay, so here it will VF2 square. Okay, so now VF1 square, VF2 square. Now what we can write here? VW1. So okay, so this is there now. So now VW1 minus VW1 square minus VW2 square plus VF1 square, because we can take here, if reaction turbine na VF1 equal to VF2, VF1 equal to VF2, so it will be get cancelled. VF1 equal to VF2 in the reaction turbine. So this, what we got here, VR2 square minus VR square equal to VW1 square minus VW2 square we know. So right, this is this VW1 square minus VW2 square I know. This will substitute in the equations number 1. This will substitute in the equation, give this equations number 3 1, 2, 2, 3. So substitute 3 in equation. Substitute equation 3 in equation 1. So what we'll get here? Degree of reaction VR2. So VW1 square minus VW2 square divide by 2 VW1 square plus VW2 square into VB blade velocity. Now A square minus B square, what is formula we know? A square minus B square, nothing but A plus B, A minus B. This formula we know. So here what we can write? VW1 plus VW2 into VW1 minus VW2 divided by this one, 2 into VW1 square plus VW2 square. Okay, so plus this, what is V square not there, no? Here is square not there, V2 VW1, this is square not there. VR2 square, so VW1 plus VW2 square. So this will get cancelled. This and this will get cancelled. And next I will write here itself. See here. You know this VW1 minus VW2 is equal to VB. So we can write here 1 by 2 VB by here VB. VB will get cancelled. Into 100 is called 50%. So what proof we did now? Degree of reactions is 50%. So this way we can prove these derivations. So this very important questions, objective question and subjective questions also they are asking. So question prove that degree of reaction is 50%. Okay students, watch this video, concept carefully watch, because so many objective questions, competitive exam questions they are asking. All will solve the numerical, so get related numerical also will solve not this formula, and all will use VW1 minus VW2 VP, this relation will use when we'll solve these questions. Okay, students, thank you.